Hello, good morning. Okay, so for today, we'll be looking at the CRT section of the computer, which is one of the connector for regulating the band of colors, or we can say the colors that usually come onto the screen, okay, to give out that outlook, or to give out the look of or to give out the colors that we usually see on the screen. So in our video today, we'll try to look into the schematics of Dell and Aka Aspire. So we'll start with Aka Aspire, and then we'll try to also to relate on to Dell. Okay, so with me here I have the data sheet. This data sheet is for Aka Aspire 50, that is 5733. Okay, so this is one of the old model laptop. Okay, so for this we'll try to see the LVDS together with the CRT section, but today our focus will be on the CRT section. Okay, so let's try to jump in. We look at the block diagram of Aka. Okay, so this is the block diagram of Aka Aspire. Okay, so it's one of the old computer which don't have the NVIDIA graphics, as you can see here. It is there is no NVIDIA graphics. Okay, so it's one of the old model. Now for the CRT section, it is one of the section that produces the signals. So the signals are red, green, and then we have blue. Okay, so those signals, they come from the PCH. So the PCH is one of the components, the biggest chip of the computer that produces the signals. The signals are said to be CRT signals. Okay, so the CRT signals, they go to the CRT connector. So here we have the CRT connector. So the CRT connector is found on page 23. Okay, and its source of signals, it is from the PCH. Okay, so we have Intel PCH, like in our computers we have Intel PCH. So this Intel PCH, when it has a problem, for example, okay, or maybe it's not giving out the signals, okay, we cannot have the colors from here. Okay, so it will be more difficult for us to have the band of colors, and when mostly it's not updated, when the computer is not having the updates. Okay, like from here, as we can see from here, if I open up the device manager, okay, so from the device manager there, if the graphic card is not fully updated, okay, like here, if we don't have these graphic Intel drivers, then automatically the colors, or maybe the screen itself, will not have that high quality definition. Okay, so here these signals commonly have to be updated regularly. Now let's try to see the actual chip, which is the CRT connector. So our focus is on the CRT connector for today. Okay, so let's jump in. We look into the CRT connector. So this is one of the CRT connectors. Okay, so the CRT connector receives signals from the PCH. This is the PCH. Okay, so the PCH gives the signals in this direction. So this is the direction of signals. So these signals are coming from, we call these as from signals. Okay, so there are two directional signals which are sometimes called the B-die. So a B-die means two directional signals. So here we can have this side and then this side. Those are called bi-die or B-die signals. Now the three signals that come from the PCH, they are red, we have green, and then we have blue. Okay, so these are the three signals. Let me try to zoom in so that we see them. So we have red, green, and blue. Okay, so these signals, they come from the PCH. So even here we can see the PCH. This is the PCH, as we can see it. Okay, this is the PCH. Okay, the PCH here, we have three band of colors. So the three band of colors, we have blue, green, and red. All these signals, they go on to the PCH, okay, or the CRT. They go to the CRT, okay. So these signals are the ones that goes to the CRT section, okay. So for these signals, commonly, as they are coming from the PCH, they go through the 1 ohm resistors. So here we have 3 1 ohm resistors. All these 3 1 ohm resistors are connected to the ground. So we call this as the digital ground. So there are two types of ground. There is analog ground, and then there's a digital ground. So if you have some series of lines down there, we call that as the analog ground. So this is the digital ground. So this is the other name for ground. This is the symbol for ground, okay. So these resistors, okay, in front of them, they are connected with the 3 ceramic capacitors. As you can see, these are ceramic capacitors. So a ceramic capacitor, these capacitors are non-polarized, meaning that they don't have positive or negative in them. So these they can be placed any direction. You can place them any direction and they won't show any effect, okay. So there is no positive and negative. So there's a difference between ceramic capacitors and the chemical capacitors. So chemical capacitors and ceramic capacitors, in their picture, we can see them, okay. So this is an example where I can show you the differences between a ceramic capacitor and a chemical capacitor. So as we can see here, this is a chemical capacitor, okay. So it is polarized, okay. It has positive, as you can see there is positive, okay. There is positive and negative. So the negative is commonly from the ground. So ground gives out the negative. And then here, as you can see, this is a ceramic capacitor, okay. This one here, what we are looking at. So this is a ceramic capacitor, these ones, okay. These are ceramic capacitors, just like this one here. We have the ceramic capacitor, okay, ceramic capacitor. Even this one is a ceramic capacitor. Together with this one here, it's a ceramic capacitor, okay. Some other components, I'll try to explain on them as we look into the other videos. So all these are ceramic capacitors, okay. So ceramic capacitors are non-polarized. They don't have positive or negative, okay. So they are different from these. These, they can't be placed any direction. So if you place them in an opposite direction, basically they will get damaged, okay. Immediately they will get damaged as you switch on power. They will get damaged. So that's the difference. So let's get back. We proceed, okay, with the discussion. So these are 3 ceramic capacitors. So these 3 ceramic capacitors are all connected to the ground. As you can see, this is the ground, okay. And then ahead of the 3 ceramic capacitors, we have inductors. So inductor is a coil, okay. An inductor is a coil. These are coils. So let's try to see what a coil is. So here it is a coil. This is the coil, okay. In odd forms, like in odd times, the coils were the winded copper wires. The winded copper wires are coils. So these are new components, okay, which are called surface mounted components. So surface mounted components, commonly, you can't see the copper winding on them, but just seeing the outlook of the component, you're able to see this is an inductor. So these are inductors. As you can see, this is an inductor. It's a coil, okay. So for the inductor, its symbol, this is the symbol for an inductor. So there are 3 inductors, okay, that are present in the lines of red, green, blue, okay. So these are inductors. Inductors are represented with L, okay. So L means an inductor, okay. So these are inductors. So these 3 inductors, okay, they are ahead of them have the filtering capacitors. Now how it is, or the way it is, just whenever you have the capacitors in front of the inductor, okay, in front of the inductor and then capacitors, the capacitors that comes after, they are said to be filtering capacitors. So these are 3 filtering capacitors. We call them filtering capacitors. So the filtering capacitors, commonly they regulate the amount of voltage that has to go to the actual line, or maybe to